Yeah.
Good morning.
Good afternoon.
Yes, well, not all of us are over on the west coast of the U.S.
Good day.
Hey, Deb.
Hello.
Yeah, sorry, team, I got delayed. Good morning, team.
Good morning, Sammy.
So we have a couple of items we want to discuss today. Any opens before we get started?
None here.
Okay. If not, let me share this document. So the number one I would like to get it discussed is you're seeing the document, right? Okay.
Yep, we see it.
Yeah.
So we were thinking about 4 different presentations to the OCP Global Summit. We do need to finalize it. One is the Workstream update. And second one is the IEE work that we are doing, basically like the information about what is IEE and the definition of it, and also what is the profiles, the work we are doing, and we want to really like dedicate a session to go through the IEE part. The other one we are thinking is the performance part that we started working on it, right? We do need to do some more additional work. I think given now until October, we will be making more progress here. So we want to really like focus on and deliver a clear message, what we want to accomplish out of it, and what is a pending item or what is needed there, right? And the fourth one, what we are thinking is, can we get a panel? The panel basically like focusing on utilizing the sustainability metrics and how are we going to bring efficiencies to the data center. So all the numbers is going to tell you what is currently you're operating, but we want to improve it, right? What we really want to do. The thinking is when we had the discussion last week, let us start putting some names, then we can reach out to the teams. And even we have to find additional people and add it. And finally, we need to decide at least the maximum number of people in the panel going to be 5. We need to decide who we want to put on the stage and how do we want to organize it. Even though the names I put, it's kind of temporary, but still we need to finalize that. I'm trying to get opinions from the team here, given we have more audience today. Or
yeah, if we have more people, maybe the folks that weren't here last time could add some proposed panelists, right? I already gave mine, so.
Yeah.
Or if the folks that weren't here last time, if you think the panel is a bad idea, then you can tell us that too.
Yeah, what about Babak? Do you have any opinions, or Jeff?
Well, we're in a different world here. We're in the co-location market in Europe,
Right.
and the existing efficiency levels for IT stacks are horrendous. Their utilization of CPU, we just certified the Swiss stock exchange. They're very interested in getting certification for efficiency, and their DC flows are really good. IT stacks, their really utilizations are really low. I just came from an IT conference in Munich with a bunch of IT operators at this company called CheckMK. They have software monitoring of IT stacks. It's a product. And again, the German stock exchange was presenting, and they're saying, they're barely keeping their CPUs at 10% utilization. So I can bring, this will be a co-location sort of market kind of opinion into the panel. I can propose folks. We have a consortium here of industrial and academic people looking at this.
Yeah, I would say the low utilization is not just a co-location story.
Yeah,
I think it crosses the industry.
Right, although, but Bach, do you have a feel for, is that because this is owned infrastructure, right? So it's co-located because people don't have their own data center space, right? So they use colo space for that reason, but it's provisioned for some peak event that only happens once a year, only happens infrequently. And so these utilization numbers you see are just what the averages are.
right. So I think we're talking about the entire customer. I mean, we're basically talking to customers. We only sort of came alive a couple of years ago. We're barely just talking to the IT customers because we've been talking to DC customers until now. We figured let's talk to the DC folks first. The DC folks are actually doing a decent job. There are a few companies that are basically consolidating the entire market. It's Equinix, Digital Realty, North Sea, Stack Infra. They're reaching pretty high levels of efficiency in their DC flows. But their IT customers we talk to, these people rent space, they set up servers. They have no idea that they're buying expensive electricity. They're not even using it.
Right.
And
okay. Yeah. So you think there's a lot of room for optimization. It's
there is
not
a
that
phenomenal amount of room for
Okay,
optimization.
okay.
In fact, if these guys had an idea as to how to reach their outcome with properly, they would probably even buy a lot fewer servers just to create that load.
Right,
Sustain that
that's the
load.
question. Yeah, because you're right. You can do everything right. You can have a modern data center that's very, very efficient, and it's all allocated, but it's not all utilized.
Yeah. So that's one of the pitches that we have in our slide deck, which is in Europe, all appliances are rated, and you can have a AAA plus rating. If you run a full load with a triple A plus, it's still a full load with nothing in it. That's a waste of energy, right? You could push that energy and use it somewhere else. So I could give you guys perhaps. So where is this panel going to be held?
This would be at the global summit in San Jose.
In San Jose. Okay, yeah. So we were actually thinking of coming to that one too. That will be my first one anyways. But I can think of people to suggest for the panel that would bring.
If you haven't been there, Babak, it's quite it's impressive. It's at the San Jose Convention Center, and it's literally 4,000 people. It's a lot.
I mean, I can also invite myself, but I feel bad about inviting myself.
No. I think
you can invite yourself. Absolutely.
Right.
Yeah.
Can I put you right now on the to be on the panel?
Yes.
Or if you want you'd want to take an AR and see like you want to invite somebody else, or
absolutely. We'll definitely. I mean, we'll figure out who to send, but we'll definitely contribute to the panel. It would be great to be at the OCP Global Summit.
And I think, Babak, if we come at it this way, I think obviously our primary, most of us are engineering backgrounds, right? So we're really trying to inform and understand, right? We want people to know what their utilization is and what that does in terms of power efficiency. It certainly can be used to shame, and it can be used to regulate. And there's, we're not going to stop that from happening, but that isn't necessarily the primary objective here. The primary objective is to see it so you can improve it. Right?
Yeah, absolutely. And in fact, that's how we started too. We're completely orthogonal to regulation because I'm from Switzerland, so we're not in the EU. But we don't really care about regulation. We're only talking to people who want to find out how they're doing. We started with going after certification, but then we realized that we built a platform online that allows people to enter their information and gives them an index. And that's super useful for customers, even without certification. They get an idea as to, we have an IT index, which is on the same scale as a PUE. And that gives people an idea as to how well they're doing. So
I would love to see an overview of that IT index. That sounds cool.
I did a presentation briefly at the Wednesday monthly last year, but I can also give you guys a brief update here too. So,
or if you just share the presentation, that probably would be fine.
So the KPIs are, we just have classes of KPIs in the presentation, but the actual platform, which is the final sort of closed form of the index, is not open at this point, but I can present it to you. I can give you a slide deck with the class of KPIs that we're looking at. And
I think that will be good. I think if you have the materials, you can share us, and we can also spend some time to kind of walk through that. It will be helpful.
Yeah, and I'll be more than happy to show you the platform so that you actually see what it looks like online. It's a SaaS platform.
Okay. Yeah,
Yeah.
let's probably schedule maybe in the future meeting to come for you to come and present it.
Sounds
Yeah,
good.
just so that you know, right? For this, you really want to be talking to the IT folk, and IT folk would not tend to come to this conference, right? But the point of having you on the panel would be for OCP people to just raise their awareness that, I've had many people say to me, like, IT load is IT load, and that's not really true. And we need to ask our colleagues on that side of the industry to do their part.
So,
right?
so
And
Deb,
that's what
yeah.
your tool is enabling, right?
This is a really good conversation. I don't want to take over Sammy's time here, but I go to both of these conferences. I go to DC Flow conferences. These are all construction people, right?
Yes,
You have
wonderful.
Schneider, Legrand, those guys. And then
Yeah.
I go to IT conferences where you have the IT operators. These two groups are completely separate, and neither one
Exactly.
of them really cares about the other guy. So
Exactly.
Good.
Exactly. You're like my brother, because I try to go to both worlds too. So I'm really glad to meet somebody who's taking the same approach.
Yeah, so then I think we'll put you back on the panel here, right? So
sure.
I have reached out to both Che and Marinda, and looks like they were off, and they probably respond next week. And I have not. Looks like Priya's mails are bouncing back, Deb.
So I replied to that, Sammy. My
Okay.
most recent email from her was this month, like June 5th.
Okay.
So, and she was still showing that Google address. So maybe try again, or you can try to contact her, through OCP as well.
Okay.
Yeah, I'm still working through my contacts, and then I'll give an update by next week, in an email. So then we'll see, who I can rally up, Yeah.
Okay. Okay. Yeah, we are trying to collect the names. So then we want to really finalize the max 5. Then let us probably, like, in a future meeting, we will come back and finalize the name, right?
Yeah.
But yeah, back we will have to have you there. So then let us. A couple of items really need to spend some time and nail down on the definitions. One is the ideal power, and another one is the load. What is the load basically means, right? These two. Let us. Which one we want to take today? Probably will have enough discussions. I know we want to have a discussion on one item. At least try to finish as much as possible. Ideal power or load?
Yeah, take the load, So ideal, we can define it, pretty easily.
Right.
So to me,
yeah, it's not even that. It's not getting easier based on some of the discussions. So yeah, okay.
Sure. Yeah. No, I'm fine with that, because I thought quite a bit about. Yeah.
No, I'm fine with this. This is, in fact, I also want to get this defined, right?
Yeah.
So zero load basically means no workloads are running. Infrastructure services may be ready. I think I should not say ready. Right? Anything until infrastructure ready, you are not going to land any workloads on it, right? So you're anything that less than the ideal power. I think the ideal power, if you go back, what we are trying to define is your infrastructures are running, but no workloads are running. So that means until that, your load is 0.
Right. Yeah. One of the things we have found in prior discussions on this topic is the necessity to qualify that idle state, like an active idle or a responsive idle, or a low latency idle. Right. The issue being that, like you say, infrastructure services may be ready. The system is not in a high latency, low power sleep state, right? Which is, you could do that by qualifying this to say that it's not It's not asleep, right? It's responsive. We're going to need more definition and more qualification of what we mean by zero load condition, right?
And I think at least definition side, can we agree that from sleep or a boot until the no workload is running? That is the clear point, right? Maybe separate it out, right?
Yeah.
And when the no workload is running, the state of the system can be anywhere in sleep to what do you call a standby to come back and running infrastructures, right?
Yeah.
So,
Well, are you intentionally trying to include everything from S5 to active idle, or are you trying to specify active idle?
that's also a good point. I was thinking active idle until yeah, then people will keep arguing there, right?
Yep.
Yeah, then let's say it's no workloads running. Let's see whether this definition works. Infrastructure services ready. This is what we set equal to idle power. Maybe say let us equal to. Is that comprehensive?
Yeah, that's better. Yeah. Well, let's just keep going. We may find that we need to qualify this further.
Okay. So then the 100% may be easier. What we are trying to say is workloads are running and reach the max power limit of your platform.
Yeah, but now you got a different problem.
Right.
Yeah.
Not the max power that it's provisioned for, or the max power that is theoretically capable of reaching under a virus condition. It's the max power that this workload will achieve. Right.
Yeah.
And that's not a hard, fast number that you can find on a brass plate, right?
Right. What is the when
I mean,
we
you
say
can
people talk about 100% load, what we are meaning there?
yeah, we can treat it as, for example, right? The CPU is running at the max, right? Utilization level, and all the other subsystems are running at the max level. And then, so I mean, you have reached, the maximum allocatable power in a way, right?
No, but you
From the
can
compute
have
angle.
IOs running at max versus CPU, or CPU running at max and IOs lower, right? It's possible, right? Depending on your workload.
Well,
Yeah,
and
depending, I
I
mean,
would say also the fans are a large contributor to this.
yeah, when
How-
CPU, say, if you take CPU benchmark, right, you're,
Right.
running to the max level, 100% utilization, and then also fans are running at, maximum level, right? And then if you need, you can go back and tweak in, and then make sure that you run to the maximum PWM settings also. And then based on the workload, whatever, exchange happening in the IO complex, everything is max in a way, right? If you need, we can inject another workload and make sure that it reaches. So that you can define
Now,
as
how do you
in a
reach
way, right?
max all the thing, right? If you want to reach max on CPU, max on IO, max on a fan, and
Yeah,
if you
right. We have run that, when we did the high temperature ambient experiments, I used to run 4 workloads
No.
in parallel to make sure that every part of the server complex is utilized to the maximum degree, right? So we used to analyze running just say spec CPU benchmark, then you go up and dial up, something else, hammer, or go back and dial up some other, if the internet, we used to
So
load multiple workloads.
So
right?
what if your
right.
TDP is not allowing everybody to reach the max? You have to throttle somebody down. Then you have a choice of either throttling CPU or IO or memory or whatnot, right?
Yeah, definitely. So how we used to do was we load one workload and look at all the utilization patterns, and then go back and inject multiple workloads to make sure what all we can dial up, and then we have a theoretical calculation and see what is achievable versus what is measured, and then we used to say what is the max condition, right? So
for the definition here, what we want to state here, I think that's what.
So I would like to bring back what Eric said is, what's the max for this workload? And that is the philosophy that's taken by CERT, which is also from the SPEC organization, the Server Efficiency Rating Tool. And that's been picked up by many regulators. So CERT presents a certain number of workloads, and it finds for each, and some of them are memory intensive, some of them are CPU intensive, some of them are storage intensive. And it, the power meter is put on the system under test, and the test harness finds what, through experimentation, what's 100% load for this worklet, and measures the power on that, does it multiple times to be sure they know, and then 100% for that worklet is known, and then you can get 100% for every other worklet, and then you combine all that together to get a sense of what's 100%, a reasonable 100% across a variety of types of workloads for this.
So I think here what we are assuming the system is running, I need to understand what is a percentage of the load that is currently running, right? I know the 100%, it's a theoretically you can do offline work. Here what we are really after is when the system is running, how do I know it reached 100%?
Well,
Right.
So putting Babak back on the spot a little bit, if you're a colo guy and you can't go put workloads on the machine like Gopi was talking about, he can't go put work on that machine because he doesn't own it. He's hosting it, someone else owns it. If he wants to see what its load is and what its peak load is, he can just observe maybe at best, right? And even then, you probably can't even observe those systems. You'd have to ask your tenant what their load is, and if they tell you, then you know, and if they don't, then you don't know, right? So I'm a little confused under this. So what is the situational, the operational flow that you're trying to support here with this load definition? How and where is it used?
So when we are defining IUE, where is the formulas here, right? Not this one.
Yeah, here is the same picture. In the bottom right hand side, you have idle power, right? And then also max power in a way. Right?
Yeah. I think we had the another one.
Another slide. Yeah, I remember that.
Let me. I think this not this one. Let me bring it up. Yeah, it was under this one. I think, let me paste it here.
Yeah, and what I'm trying to test, right, is are we interested in the maximum load that is achievable over the deployed lifetime of this server doing what it's doing? Or are we trying to capture the maximum load that's theoretically possible on this server, even if that will never happen during this deployment?
Yeah, I think what we are trying to say is when people are talking about PUE or IUE, if you don't tell what load you are saying the number, it is not really like difficult to compare a system to system.
Yes. Yeah, agreed.
Yeah.
That's a reason when we represent PUE or even IUE, I think we are kind of saying like, maybe forget about PUE, we are after IUE here, right? When I given IUE for the system, I should also need to say the load. Then only I'm really like referring to which point I'm telling you IUE, right?
Yeah, but we're trying to talk in a general term. We're trying to make load a universal concept, right? That would apply to whatever the workload is. Where are you at the load curve of that workload? Versus a specific curve for one specific workload.
Correct.
And I think, so we're gonna have to pick something, right? We're gonna have to use, try and bottom out here on what it is we think works best, and then try to see if we can align on that and define it well enough that we'll get a disambiguated behavior out of trying to report load.
Right. So
And
here also, when we say peak load, what is the peak load basically means?
right, and depending on how the system's configured and where it came from and what's in it, the peak load isn't always the same, right? You can get certainly systems in the same form factor have different loads. Systems from the same generation, from the same vendor with different SKUs have different load, right? And to Deb's point earlier, yes, fan power can be substantial, but fans can also be massively over designed, right? When there's nothing you can do on this system that'll move the fan speed control up to its highest setting, right? So the peak theoretical fan power is 200 watts. There's nothing you can do on the system to get the fans to 200 watts. If you had bought the top bin SKU and ran a power virus on it, maybe you could get the fans to 200 watts, right? But the system you're actually looking at may never achieve that, and there may be nothing you could do to get it to achieve that,
Well,
other
and
than
there's
going into the
also,
firmware and turning off fan speed control,
exactly, I was going to say, there's also a
Which-
lot of
which
software.
is not something I think we want to go down the road of, right?
Mm.
One of the problems is, part of our audience here are customers that have literally millions of physical servers. If you want them to log in and override the fan control on each one of them, that'd take 5 full-time employees an entire year. And the return on that investment would be nothing. I mean, that's not something that's interesting to go do.
So I'm wondering whether when we say max power of that particular system reached, is it not a good way of saying it? Or?
Is it quoted?
Sammy, is that it's ambiguous. It's not clear what that means. So max power reached is a fine turn of phrase, but it is not. It's in no way an effective specification language.
So here's a question.
Yeah.
There's so much variability, even within the same parts, right? CPUs, depending on how they get configured in a form factor, that max power varies widely. So how are we specifying what the max, or are we going to measure? I guess it goes back to what Eric was saying. Are we going to measure this for every server configuration?
Yeah,
Well,
we are going to keep
another
monitoring,
problem I
right?
want to put on the table before we get too far down this discussion. When we say, if we try to come in with language like max power reached, we are now creating a different kind of ambiguity where we say load, and we seem to be talking about like CPU workload saturation, and then we say max power reached, which gives you the impression that what we're actually measuring is power. And in OCP, we could do that, right? We are actually trying to create a required profile where power telemetry is available. So we could measure load in terms of power, but I don't think that's what you mean.
Yeah, so at least 0, it's clear, it's active idle. And peak, when we say peak, what is that? It cannot go more than currently. What is the system's percent TDP, right?
Right. Well, and if you put if you put rated power on this curve, do you think it would be at peak? Because I don't, right?
I know.
I have taken 2 Sapphire Rapids in 2 different form factors, a Blade and a 2U, and I can push them to completely different TDPs, the same exact CPU.
Okay. Yeah. CPU can do, but as a system level, you're kind of reaching the maximum, right?
Yeah, well, I'm not trying to be difficult. It's a gift, right?
No, I'm hard for it. We need finally come up with a definition that we all can agree, right?
Yeah, well,
Sorry,
we just need to say this in a way where it's unambiguous what we mean, even if we haven't yet clarified how to do it, right?
Right.
And so I think what you're after here is the peak effective load, or the peak active load, something that the peak observed load, right, in the current deployment of the system. And we're not specifying yet what it is that you're running, but we could, right? I'm worried about going down that path. But
no, you don't want to go there. I mean, when you do the modeling, right? So for example, for a given node level, and then you apply all these efficiency factors for the whole system, and then say this is the power maximum you can feed in. Then when you run the workload, you measure completely, and then go back and see what you reached, right? That
Mhm.
should give an indication of what is the allowable max power you can reach. Forget about the workload, just from the perspective. Then if the workload is different, I'm running a graph-oriented workload, inter-node communication, 256 nodes I'm running, then it is a totally different ball game, right? So it's hard to measure and give what is the utilization pattern from the load angle, efficiency angle, right? But here it is a little better because PUE, you take an average or whatever it is for the whole data center, whereas PUE, you're nailing down to a node or a rack level, a sub-component of that level, right? If you specify that, that gives I think a decent indication of what is the load behavior, right?
So what do you want to put? Workloads running peak what?
Peak allowable power.
You're saying what the rack is provisioned for?
Yeah, right. If it's a 20
Like a
kilowatt
50
rack,
kilowatt, yeah.
20 kilowatt rack, you apply all
No,
the
no, no.
losses, etc., then you get only, hey, I'm feeding in only 18 kilowatt, just an example. Then you go back and, you can internalize and see what is you can do
Yeah, yeah.
some measurements. We have all the
Right.
controls and then go back and arrive at that factor, right?
Okay, okay. Yeah, my meaning of max power is to kind of say it's the max allowed, or it's a peak allowed. Yeah.
Yeah.
Can you, maybe it doesn't stay for the long run, but can you just, for us to remember that we came to this conclusion, say this is, rack provision, for example, 20 kilowatts or whatever. Can you just jot that down so that
Yeah,
we
yeah.
remember it?
Node/rack provisioning or something.
Max rack provision number and
Does it make sense, So just want to make sure that, kind of, right?
Do we know the sled provision power of the?
yeah. Each slide will have its own max, right? That's what
Mhm.
I was saying. TDP max TDP per slide. So what we are saying is max provisioned power for the sled, right?
I'm not
If
so
you
sure.
reach,
Yeah, I mean, yeah, and then of course we do have the problem that the rack could be provisioned for 50 kilowatts, but right now it's only half full.
command depth, like if you provision for max and you are operating at 50% on a rack.
Well, you just don't even fill for whatever reasons, the rack isn't full,
Correct.
right?
Right.
So. But
Yeah,
you
that happens
still,
all the time, right? In a way, right?
Yeah.
So people may load everything, or they may do half
Yeah,
and then expand it
that's
later,
why
whatever
we
the
have
case,
this
right?
one, right? But we are saying
Uh-huh.
rack load equal to each server's load,
Yeah, sigma of,
right?
yeah.
Sigma of that, and your max active power on the thing, then you get the rack level of load, right?
Yeah.
It's basically like, again, you can say, if I know IUE of every single server, then I can multiply your active power and you can come back with active load on the rack.
but I think we're still back to, do we know IUE for every sled?
That is what we are after, right? Because if I know that, I can compare. If somebody says my IUE, and if I say on 50% my IUE, then okay, how much power you are consuming, right?
Yeah, because you're right, Sammy. So you have to take at each every node, sum it up, and then give an indication. If it's only half loaded, let it be fine, right? Whatever it is, right? So.
Yeah, we could make a case, I think, Sammy, that at least in an OCP context, IUE can only be calculated at the rack level.
I feel more comfortable with that.
Well, and what I'm thinking is, if we look at OpenRack V2 or OpenRack V3, right? there isn't a silver box power supply in every chassis, and certainly not in every sled, right? There's one in every rack because you're doing DC
Yeah,
power
mhm.
delivery. And,
Yeah,
and
but
so since you have to include that conversion loss, you can't, you have to do the rack level and then figure out this level if you're going to do the sled level at all, right? So you might as well just do the rack level.
but as a definition, you won't have it, but implementation side, you can recommend, yeah, I think a rack is good enough, right? But the reason is I'm kind of saying is somebody is selling a system. Do they want to advertise this number so that, like when I'm buying a system from, I don't know, vendor X versus vendor Y, I can really compare it rather than putting on a rack, because when you put on a rack, you are loading a network and other things on top of that, right?
Mhm. Yeah.
Yeah, you
Network storage and other
definitely are.
things.
No, I see
Top of the rocks.
the issue,
Mhm.
right? But I think we're going to end up with, you remember the whole notion of a partial PUE. I think we're going to have the notion of a partial IUE, right?
Right.
Because to have all the terms in it, you're going to have a rack level value. And you can try to then compute the value that's applicable to each of the elements in the rack, but you're going to need to go all the way to the top and back down. You can't start at the bottom and build up.
Yeah, but even when we say IUE, for what load we are meaning, right? I think we need to have at least a language, right? If you're always saying 50%, the one I'm going to tell you, so that it's normally average that people can compare.
Yeah, that's going to be difficult, right? So it gets us into another complexity, right? Where
Right.
if you take these 2 points together, right, where your full stack of non-IT power has many shared elements, right? Which we've talked about before, right? So there's this conversion loss for AC to DC that I'm talking about in the power shelf, and then there's shared fans across multiple independent server modules or sleds, right? Where the fan power isn't allocated to a single sled either; it's divided across multiple. And then we have the problem where the utilization on each of those sleds may not be the same, right? They may not be in the same load balancing pool. They may not be running the same class of workload. Right?
Exactly.
Sure. Yeah. Yeah.
But
Mhm.
a rack
Mhm.
level, what's the rack level utilization? Well, it's a blended average of whatever's in the rack and what they're doing, right? So I'm starting to get a little concerned about this notion of comparing infrastructure A to infrastructure B at a particular load. Is that actually a useful thing to do?
If no, it's not related to the thing, right? When somebody is telling IUE, unless I tell what load I'm telling you IUE, it's not comparable in IUE basis, right?
Right, but the load is incidental, not deterministic, right? Especially at a rack
Right.
level, right? Your
Right,
rack
right.
could have 20 things in it all at different loads. So what's the rack load? I mean, this seems to have the mental model that the rack is homogeneous and everything in the rack's in the same load balancing pool, and if the load balancer works, everything in the rack's at the same load. That's not a common condition.
If anywhere.
I mean,
Yeah.
it's going to vary based on the topology, how they deploy what workload. At least at a node level, you can measure it, right? And then if you want to publish at the rack level, probably we may need to look at it, how we want to elevate, because each and every server may be different, right? Doing the different things.
So
It
if
gets
I'm
harder.
buying a system,
When we do load-based or load specific metrics, or we specify the load at which a value is applied, that feels like a per server thing. But to get that per server number, right, like I said, we're gonna have to go back and take multiple servers that share fans and take your share of the fan power and the whole rack and your share of the conversion losses, right? So generating this, there isn't any clean way to generate a server metric just at the server level, I don't think.
so if I'm buying a system, right? If the system vendor tells me, probably, I don't know, 4 different point or 5 different point. Here is a load 0 number, load 30, 40, 50, 60, and 70 kind of numbers. Then I'm basically telling you this graph, right? then based on the data center operator, they can say like, hey, my sweet spot may be around 60. I want to be optimized for 60 than 30. Right? That's the reason I'm trying to see like.
But this is basically isolating that server and evaluating it according to this graph. So the rack and whatever is shared is gone.
No, then once you put that, and when you try to populate the servers on a rack level, it may not have a same server from same vendor, right? You may have a different server sitting there. Then you can really say the similar thing for rack level, right? Rack level load, 0 to load peak, you will arrive something, what is you, again, each vendor may have a different sweet spot on their data center, right?
Yeah, I'm struggling with this usage of this intended use of IUE. I'm struggling with it.
Right. So from performance angle, we know that flops, teraflops, etc., etc. IOPS request, database request, whatever it is.
Right.
From the power and right, metric angle, as Eric say, is hard. There is no. If we try to design a factor which helps the decision making of a customer buying servers, is not. When I say IUE is X, you cannot use it as a decision factor. Yeah, there is a problem. No question about it, right?
Yeah, we do need to put a IEE graph on top of the right. If I say IEE is from here to here is all one, right? I think we are not put that IEE factor on here, right? That means all the power that you're giving, it goes to compute, right? It's not wasted.
Mm-hmm.
But if your the IUE here is kind of too high, and when you go here, it's probably like going something like this, then again the maximum, let us say maximum operated system, maybe 50% only going to compute, and the remaining 50 is going for non-IT, basically fans and power conversion and other things, right? Your system is really not efficient, right? That's what we want to bring it here, right?
There's the origin of the
but
IUE
that doesn't
metric
mean
in a
that it's
way,
part of-
right?
Correct.
That doesn't mean it's part of marketing the system, though, right? What we're trying to, I think we're better served if we keep our IUE usage model to in situ what is happening, right? Now that it's deployed in this configuration, in this environment, what is the IUE, right? We're trying to figure out how much of the power is useful power versus overhead power by a definition that we're struggling with writing down right now.
Right.
And that's something someone would want to know about the deployment. And obviously they'd like to know how to improve it too, but I don't think you improve it by ordering a different system from your vendor.
No, you're not ordering it, but at least if you start measuring it, you will know, I think, what.
Yeah, but I'm just saying, I don't think the guy selling the system can tell you what the IUE is going to be, right? You have to deploy it and go look at it and then try to improve it. You don't buy an IUE.
I can tell you the customer's perspective in situ, right? The customer cares about the electricity that's coming into the server, not necessarily in the rack, just the server, forget about anything that's shared. Out of that electricity, how efficiently are we using it?
Right.
That maybe we can separate the metrics. Okay, here's a server-centric metric. Here's the electricity coming in. How efficient is the server actually using that electricity? And then have other components of the rack brought in.
And what can people change to improve the efficiency?
This graph is a perfect example. When you increase your load, you're a lot more efficient.
I agree. And I just want to make sure we were on the same page.
Yeah.
And but at this point they're not going to go redesign the rack or mess, like Eric said, they can't fix the firmware on across the fleet. It's to somehow run the fans differently.
Now, this is a
But they can change the consolidation of their workloads.
Yes, exactly.
Right. And I think you guys are looking at it. I mean, I think there's several lenses here, right? There's a lens of how do I compare servers from a marketing perspective? How do I, deal with the fact that I have shared resources at the rack level? And then the other lens should be what the customer is actually doing with the server, because that server in situ deploy also has efficiency characteristics, which could, if we come up with the proper metric, could help the user use the server properly.
Well said. That clarifies when you remember that we have those multiple lenses. I would put forth that for comparing servers, we have spec power and we have spec cert, and then others will have already picked their own, like be it spec at 100%, and they'll measure it themselves. And, they're huge volume buyers that can push things the way they want it. So I don't know how much play we have there, rather than accepting the, what's decades of work to get us to where we are now with spec.
Yeah, I think mostly the cases, right? You're not, data centers are not operating at 100% peak, right?
Absolutely not.
Right.
No, not at all.
I just gave you two examples at
Exactly.
6% and 10%.
Right.
Exactly.
Yeah, it varies from like 40 to 60-ish. Of course, depends on the workload. I met with one of the customer, they loaded to almost like 80%, right? On a 16,000, instances of the databases running. So they have a threshold, they try to manage within that.
How do they measure their 80%?
I cannot tell here, but I can glad to
Wow.
share, yeah.
The Barroso and Hutzle book on data centers from Google also
Yes, great
has
book.
it's a 30% or 60%. I mean,
So where do we go from here? Like what I was thinking is this is IE graph, right? Maybe I just label it something here, right?
But again, what level are you checking at? Are you checking at the rack level, at the?
Yeah, you can apply this for anything, right? Can be system level, rack level, or multi-rack level, however you want to aggregate them together, right? You want to try to get a flat curve. If you get a flat curve, then you are really like super efficient, right? If the curve is very like going down like this, you're not that much efficient, right? And we do need to understand what that curves looks like, right?
Yeah, so it may work better in terms of making progress on this conversation, right? It may work better to work on this articulation of what it is we're trying, the situation we're trying to address, and then get into like this kind of what you have in mind, the vision of being able to plot an IUE and plot it for various scales of the infrastructure. We may want to do an articulation of that and then talk about what we're specifying, because then you can tie it back to where you are in that context. So I think right now we're getting lost. Like you have something in mind, Sammy.
Okay.
That we are not aligned on, and the rest of your audience here is jumping all over the place.
Okay. Maybe I think that's a good segue. I mean, yeah, to kind of I think what we really after, right? I think it's really about the panel thing, right? Hey, using the metrics, what do you want to really achieve, right? One of the thing is what really need to look, if I know the IUE and that's what I'm right now operating, can I move this graph flatter, right? Can we go somewhere like this, right? That's what we want to see. But right now, I don't know what is the numbers right now, right?
Right.
I
But let
think
me,
we can go offline and do some modeling. Okay, put a calculator, look at some measurement, and then hopefully that will help in refining the definition. Right?
okay. So let me do anyway, we are on the top of the hour. Let me write it down. Maybe I think it's good to have some view. I think like Babak also said, right? Having some viewpoints. So I think writing it down and we look at it, then come back to that discussion on that load, right? Maybe the word load maybe may not be good. We need to figure out a different name, but let us come back.
Yeah, that sounds good.
Okay.
And then
Good, I
also
think-
we may need to revisit the IUE. Why, re-emphasize
Right,
again
right.
why we are doing that. There is a better index compared to
Right,
the PUE index, and why we are promoting that, right? So we can revisit that if required.
Okay, very good. Yeah.
Thank you, Sammy. Yeah.
Okay, good. Thank you, Tim. It's a really good discussion. Thank you. We'll see you next week.
Bye.
I think so.